Right, so with the nature of the roots, Now remember, if you think of the equation y equal to ax squared plus bx plus c, okay, that's the parabola, right? Y equal to ax squared plus bx plus c, that's the equation for a parabola, okay? So when you look at, let's say we just look at the basic parabola. Let's say it goes like this, okay? Then, when you put it equal to 0, 0 equal to ax squared plus bx plus c, and you solve x, because you put it equal to 0, if you solve x, what are you actually doing? You're actually finding the x-intercepts. Remember from grade 10, when you put an equation, when you make y 0, you're on this line, the x-axis. Okay, you're on the x-axis. Okay, so when you are on the x-axis, it means you're finding your x-intercepts. Okay, that's what happens when you put it equal to 0. Okay, so this line, okay, remember there's y, okay, this line is called y equal to 0. So I put the equation equal to 0, and that means I'm solving my x-intercepts. So when we use the equation x equal to negative b, the quadratic formula, plus minus square root of b squared minus 4ac over 2a, when I use this quadratic formula, what am I actually doing? I'm actually finding my two x-intercepts. Okay, like let's say you substitute this and you get x equal to 2 or x equal to negative 3, then that's going to be your x-intercepts. So that's the whole idea with the solving quadratic, all these things we've been doing with quadratic equations and quadratic formula. We're trying to find out where are the x-intercepts for the parabola. Okay, in the same way as with a straight line, when you put a straight line equal to 0, you find the x-intercept of the straight line. Okay? So, but now this part is about the nature of the roots. What are the nature of the roots? That means, remember the roots are your x-intercepts. Okay, they are called the roots. Okay, you also call it the x-intercept. It's the same thing. You can call it the roots, or you can call it the x-intercepts. So nature of roots actually means the nature of the x-intercepts. So what is nature? It's like, what are they like? What are the x-intercepts like? So what can they be like? They can either be real or non-real. When will they be real? Think about it. If b squared minus 4ac, if this part here is negative, then what happens when you type the square root of a negative? You can remember when you type in square root of a negative value, it's undefined. It says an error on the calculator, it's undefined. So you can't find roots if this part is negative. You can't find the roots. How is that possible? What would it look like if a parabola doesn't have any roots? No x-intercepts. If you, for instance, draw a parabola there, can you see this parabola doesn't have any x-intercepts? So it means there's no roots. It can happen. So b squared minus 4ac can be smaller than 0, and then you can just say there's no solutions, which means the parabola doesn't go through the x-axis. That can happen. Okay? So the one option is to say x small, to say b squared minus 4ac, this part here. We're just going to focus on that part. We can say if b squared minus 4ac is smaller than 0, okay, then you don't have roots. No real roots. Does it make sense? There's no real roots. They're non-real. Okay, because if this part is smaller than 0, it means this part is negative. And if this part is negative, what can you say about the nature of the roots? They're non-real. You understand? It's non-real. There's no roots. Okay? So if b squared, obviously then if b squared minus 4ac is bigger or equal to 0, you will have real roots. Okay, so that's the one thing you check for. When you get the equation and you only focus, remember the question will probably say, if it says determine the nature of the roots, you should know I don't have to find it. The question didn't say find the roots. It just said determine the nature of the roots. Not what are the answers, what's the nature. So then you just check what happens with b squared minus 4ac. If it's bigger or equal to 0, they're going to be real roots. Now, when they're bigger or equal to 0, you get different kinds of real roots. Okay? If b squared minus 4ac is a perfect square, like 16, if this part is 16, then the square root of 16 is 4. Then you can actually write it as a fraction. You can get like negative b, for instance, negative 2 plus 4 over 2 times 2 or whatever. Then you get a fraction, which is rational. Okay, if it's a fraction, it's a rational number. So when b squared minus 4ac is bigger or equal to 0, you know it's real. And if this part is a perfect square, the number, then you can say, and it's rational also. So it's real and rational. Okay, so that is what can happen. So if we say b squared minus 4ac is a perfect square. Okay. For instance, 9 or 16 or 25 or whatever, any number like that, then you can say it's going to be real and rational. And the last thing you can say, if it's a perfect square, is it's going to be unequal. Because then this part will be, like, let's say it's square root of 16, it's 4. Then it's negative b plus 4, negative b minus 4. So you're going to have two different answers. So then we also say it's unequal. It's not the same. There's not just one root. Real and rational and unequal. Okay, so that's the answer then. Okay? And then the other kind that you can get is if b squared minus 4ac is not a perfect square. Okay, if it's not a perfect square. So if we say b squared minus 4ac, this part here is not a perfect square, then we're going to say it's still real. Okay? But now, because it's not a perfect square, it means it's going to be irrational. Because let's say it's 10. Square root of 10 is an irrational number. Okay? So now it's going to be real, but it's irrational, and it's unequal. And then the last option is, so these are the options. Smaller than 0, it's non-real. Big or equal to 0, it's real, but then what kind of real roots do you have? Okay? If it's a perfect square, then it's real, rational, and unequal. If b squared minus 4ac is not a perfect square, it's real, irrational, and unequal. And the last option is if b squared minus 4ac is equal to 0. Okay, that's the last one. If we say b squared minus 4ac is equal to 0. Think about it. If it's equal to 0, it means this part is 0. So you add and subtract nothing. Then you're just left with negative b over 2a. You understand? If you make this part 0, you just have negative b over 2a, which means you only have one root. You're not adding something or subtracting something. What does that look like? If it only has one root, let's first write down the answer. Then it's going to be real, rational, and equal. Okay, real, rational, and equal. That's what it would look like if b squared minus 4ac is equal to 0. And it will look something like this. Okay, there's an example. It just touches. It just touches the graph. Then it only has one root. So b squared minus 4ac is then equal to 0.